One of the core principles of object-oriented programming is polymorphism. Poly means many, morph means form. So polymorphism means many forms, and this refers to the situation where an object can take many different forms. Let's see this in action. So here's our teacher class. Right after, let's define a function for printing the name of some people. So print names takes a parameter called people of type person array. Now in this function, we're going to use a for loop to iterate over our person array. So for let person of people, we're just going to log person dot full name. Now let's call this function and give it an array of person objects. Now you know that every student is a person. The same is true for every teacher. So in this array, we can add student or teacher objects. So here we can add a student object and initialize it with 1 John Smith and a teacher object, Mosh Hamedani. Okay? Now let's run our program. So we see different output depending on the type of person. If we have a student, we see their name. If we have a teacher, we see their name prefixed with professor. Now, I'm not a professor and I don't ever want to be, so excuse me for that. But back to our code, what you see here is polymorphism in action. And this is extremely powerful, as you will see in a minute. Why is this called polymorphism? Well, in this for loop, let's hover our mouse over the person object. This object is of type person. But in each iteration of the for loop, this person object is taking a different form. In the first iteration, it takes the form of a student because the first element in this array is a student object. In the second iteration, our person object takes the form of a teacher object. And that is why the full name property or the full name getter gives us different outputs. So our person object is taking many different forms and is acting polymorphically. Now, why is this powerful? Well, because tomorrow we can create a new class like principal, which represents a school principal, and print its name without making a single change to this function. Let me show you what I mean. So here we're going to define a new class called principal, which also extends the person class. Now here we're going to override the full name getter. And instead of professor, we're going to print principal. Okay? Now, because a principal is also a person, we can add a principal object in this array. Principal is going to be Mary Smith. Okay? Now, when we run our program, we see a different kind of output on this line. So what is happening here is that we have enhanced our program without a single change to this function. So we have implemented some new functionality just by writing new code. And this brings us to another principle of object-oriented programming called open-closed principle. This principle says our classes should be open to extension and closed for modification. So we should be able to extend them or inherit from them, but we should not modify them. Because if we modify or change a class, then potentially we might break something somewhere else and end up with a bug. If we properly test the class and know it's working, then we don't have to touch it. So we can enhance our application simply by adding new classes. So we write new code instead of changing existing code. This is the idea behind the open-close principle. Now, practically speaking, we cannot adhere to this principle 100% of the time. It's impossible and even costly. This is just a guiding principle. What I want you to take away from this lesson is that polymorphism allows us to follow this guideline. Again, there is way more to this. If you want to see more examples of polymorphism and open-close principle, you really need to look at my design patterns course. Now, one last thing I want to mention before we finish this lesson. In the previous lesson, I told you that we have to use the override keyword to tell the compiler that here we are overriding or changing the implementation of the full name getter. And this is how we achieve polymorphic behavior in this method. So the full name getter is defined in the person class, but we have changed its implementation in a couple of subclasses. Now, if we didn't use the override keyword here, this getter would be disconnected from the one defined in the base class. So someone could go and make a change there. Perhaps they could refactor that. They can change the name or restructure it, and this would break our polymorphic behavior. So that's it for polymorphism. Next, we're going to talk about private versus protected members.